All right. So, when we start with the truss, we've got a bunch of things that we need to talk through. Okay? But essentially, the end game is that we find out the forces on each of the members. All right? So we're going to start with something super duper simple here. Just a single triangle. Okay? Single triangle. That's what we're going to start with. And for the sake of ease, we'll make this a right angle. And we'll make this, say, we'll do a 30, 60, 90. Okay. So we'll start there. And we're going to put a pin support here. And we're going to put a roller support there. Okay. And then we need one force. We need one force somewhere on here. So we'll say that there's a force here, and it's 100 newtons. That's all you really need to solve this thing. Okay. If you hadn't been given the angles, you might need some lengths so that you could figure out angles. But other than that, we don't really need lengths. Okay. So the very first thing I need to do is see if this truss that I have here is even solvable using the system that we're going to use. Okay? There are trusses that we could make that won't be solvable using this system. We call that being statically determinate. Okay? Statically determinate. So I need to find out if this is statically determinate, meaning, it's a big fancy word that basically means can I solve it using the system that we're going to solve it. Okay? So I would refer to my engineering formula sheet, big engineering formula sheet, and I'd flip through and I'd say, okay, so where are my statics equations? Let's see. No. Oh, okay. So they're going to be probably in this general area. I'm looking for right here, truss analysis. Okay, truss analysis. And it says 2J equals M plus R. Okay? J is joints, M is members, R is reaction forces. If the two sides of that equation are equal, then yes, we can solve this using our system of equations. If they're not, then we can't. So, how many joints are here? Joints where two members come together. How many joints do we have? Three. 1, 2, 3. So 2 times 3 equals, okay, how many members are there? 1, 2, 3. Okay, now reaction forces. Okay, so I don't have any reaction forces drawn up there. We're going to have to figure those out. So going back to when we learned about the supports, okay, depending on the type of support, I have different reaction forces. A cantilever support has 3 reaction forces. Cantilever prevents movement in the x direction, in the y direction, and the rotational direction. A pin support has how many reaction forces? What direction does the pin support prevent movement? Remember? Does it prevent movement in the x direction? Okay. So there's a reaction force this way. Let's put some letters on this. This can be A, this can be B, this can be C. We call this reaction force A in the x direction, okay? Does a pin support prevent movement in the y direction? Yes, it does. So there's a reaction force here. Reaction force A in the y direction. Okay? Here we have a roller support. Does this prevent movement in the x direction? It does not. So there is no reaction force in the x direction. Does it prevent motion in the y direction? Yes, it does. Okay, so I'm going to replace this with a single reaction force, R, C, Y. Okay, so how many reaction forces do I have? I got RAX, I got RAY, and RCY. What about this 100 newtons? Is that a force? Yes, but it's not a reaction force. Okay, it's like a real actual force. So I have 3 reaction forces. All right. So 2 times 3 is
5. Oh, wait.
6. 3 plus 3?
5. 6.
Hey, 6 does in fact equal 6. What that means is that this truss can be solved using our system. Okay? Before you ever set up to do a truss, this should be your first step, just to make sure, because you don't want to spend, 20 minutes on this problem only to find out that it can't be solved using our method. Okay? I have never seen it like on a final exam or something, a big old truss problem, and then, haha, it's not statically determinate. Okay? But it doesn't mean you couldn't, right? So you want to make sure that you check this before you do anything else. All right, so yes, it's statically determinate, check. Okay, now we can attempt to solve this truss. Okay? I'm going to make myself a little scoreboard over here on the right side, because I like to do that. Things I'm going to need to solve. I'm going to need to solve AB, force of AB. I'm going to need to solve force of BC and force of, what am I forgetting, AC. I'm going to need those things. Along the way, I'm also probably going to need to solve RAX, RAY, and RCY. I'm probably going to need those somewhere along the way. Okay. So to break into one of these problems, I always start with a moment. Okay? When I was taught this, my teacher at the time would always say, hey, well, did you take a moment? Hey, did you take a moment? Did you take a moment to solve this problem? Did you take a moment? I'm like, ha, 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 ha. But irritatingly, I remember it like 12 years later, so it was perfectly effective for what she wanted to do. Did you take a moment? Before you solve the problem, you take a moment. Right? You need to solve for the moments on this, because that's going to let us break into this problem. We really need like RAY, or RAX, or RCY. We need some piece of information so we can start solving here. So we're going to start with a moment, which is what you guys have been doing with the moment lab. Okay? We need something here. So we're going to start with the moment. Okay? So take a moment. So we're going to pick a spot. Okay, we're going to pick a spot and we're going to imagine this truss moving. So I'm going to pick this pin joint right here. I like to pick the pin joint. Okay, the pin support. I'm going to start right here. And say, okay, imagine that the truss can spin around this point. It can. It's a pin support, right? It can spin. Okay. What is this 100 Newton force attempting to do? Yeah.
Spin it clockwise.
Spin it clockwise, right. If I put 100 newtons of force here, the truss is going to want to spin that way. Okay? So, that's providing a moment. A moment a day, okay? What is preventing that thing from spinning the truss? Why can't this just spin? There's what? There's a support, exactly. Okay? In this case, we're going to call that RCY, that reaction force because of that support. That's like, no, you can't spin this truss. Okay? So the 100 newtons is providing a clockwise force, a moment, I should say, and RCY is providing a counterclockwise moment. Those two things are at odds here. They're fighting. 100 newtons wants to spin the truss that way. RCY wants to spin the truss this way. Is the truss moving?
No.
No. So what do we know about these two moments? They equal 0 and they equal each other, right? They sum to 0 and they equal each other. That's what we know. All right. So this here, this moment, let's put some numbers on it. What's the equation for moment? Distance times You're right. Distance times what? Starts with an F. Force. Okay. Force times distance. And there's something really important to remember about the force and the distance here. We're talking about moments. What is it that has to be true about the force and the distance? We're talking about moments. Something about the way they're oriented, aimed. Do I take like this distance or take this distance? What distance do I take? Think about that wrench. All right. If I have a wrench here and I push on it that way, does the wrench turn? If I push on it this way, it doesn't turn, right? If I push on it this way, does it turn? Yeah. So what do I know about force and distance for a moment? What does the force and distance need to be? What do you call that? Perpendicular. There we go. So the force and the distance have to be perpendicular. So here's my force. It's going straight up and down. The distance then is perpendicular. It's this right here. Okay? So I need to know that distance. Well, it wasn't provided in the problem, so we better throw a distance in, all right? Let's go ahead and say this was 10 meters. Okay? So moment equals 10 meters times this force, 100 newtons. So that moment is 10 times 100, so it's 1,000 Newton meters. Is it clockwise or counterclockwise? Clockwise. So do I say that's negative or positive? Negative. Okay? So moment is negative 1,000 Newton meters. Okay? So that's that moment. Okay. Now I've got RCY. It's fighting it. What does the RCY, what does the moment here have to be?